Hey everyone, today I'm going to be doing Leetcode problem 3254, find the power of case size subarrays 1. So I'm just going to go over the problem description and then I'm going to go into the drawing explanation and then we'll code it up, Leetcode style. And so let's just go over the problem description. It's fairly straightforward. You're given an array of integers nums of length n and a positive integer k, and the power of an array is the maximum element if all the elements are in consecutive order and sorted ascending order. -1 of otherwise. So we can just ignore all that. Let's just look straight into the example here. 1, 2, 3, 4, 3, 2, 5, k is equal to 3, and the output is 3, 4, -1, -1, 3 times. And so it makes it pretty clear what's going on right here, right? So 1, 2, 3 is consecutive order, and the biggest number is 3. 2, 3, 4 is also in consecutive order, ascending order too, right? It's going to be 4. So I think the thing that's gonna stand out like immediately is that this is going to be a sliding window problem. And usually with these kind of problems, well, with the sliding window, you're going to be using 2 pointers. There's actually a much better way to do it, but first I'll just go into the drawing explanation and then I'll go into the intuition of it. Alright, so I'm going to do the drawing explanation now. And so I made this example right over here. And the first thing I kind of mentioned earlier was we need to do a sliding window. And if you don't know what a sliding window is, just think of it as a window of opportunity here, right? We have to make these subarrays that are size 3, right? And our window will be the same size, right? It's going to be a size of 3. And traditionally, they're really done with left and right pointers. And so we can just kind of reason about this example right here. I'm going to put this left pointer right over here, and then my right pointer right over here, right? This is of size, this length right here is size 3, right? So if we can clearly see that this is a consecutive ascending order. So if I just write down my result right here, I can put that this is going to be the value that we're going to put is always going to be this right value because it's consecutive ascending order. It has to be the biggest value here, so 3, right? And then we can move our window about, right? We can move our window right over here, 2, 3, 4. This is also consecutive ascending, and then you would put 4. So fairly simple. And then when we get to 3, let me erase this right over here, right? When we get to 3, 4, and 30, 3, 4, and 30, this is ascending, but it's not consecutive, so this is just not valid, right? And we will put -1 and then so forth, right? This is pretty much what we're doing here. It's a sliding window, and we are every time we're going to be validating. We're validating our window. That's it. If you just think about it in these 2 ways right over here, you can get kind of like the trivial solution, or I guess the simple way of thinking about it, right? And it won't be a TLE, right? And so now I'm going to show you the optimized way, and I actually did not reason about this myself. But if you read the editorial, first I'll show you how to do it with a deck, or a DQ, and I feel like it's pretty cool to see a sliding window with a DQ, but just think of it with a count is much more simpler. So for now, just imagine this. I'm going to put a pointer. I'm going to put a pointer right over here, right at the beginning, and we're going to keep track of the count, right? We're going to keep track of the count of consecutive ascending numbers, right? So it's going to move like right here, and then it's going to move right over here, and then eventually, once the count is either equal to or greater than k, we have to have a valid window, right? So if we start at 1, our count is going to be equal to 1. Go to 2, right? Go to 2 over here. It's plus 1. Go to 3, add 1. That's going to be 3. That's our valid window right there. And then we're going to add that to our array. And what you can also notice is that because we've gone to this point where our count is greater than k, wherever that pointer is, right? It's at 3 right now. We just simply add that to our array. So that's pretty simple. And now we can see the reason I said it can be either equal to or greater is because once we get to this 4 right over here, the count, right? The count over here, the count would be equal to 4, right? And this is also a valid window. If you just don't imagine that 1 right over there, that is going to be 2, 3, 4, and that is valid, and then we would put 4. Okay, so pretty simple. And then you would move your pointer right over here to 30, and this is the first time we're going to get kind of in trouble here, right? It's 3, 4, 30, and that is not valid, and so we can put -1 here, and we would simply reset the count. The count here would become -1, and as our pointer is moving towards 32 right here, it's still not. It's still, the count is still going to be less than k, and once we go past this like initial point, like this point right here with 3, right? It's going to always, we have to start appending to our result, right? Because this is the beginning. This is the beginning of our window right here. This is the beginning of our window, and that's pretty much it, right? So it's going to be 3, 4, 30 is invalid, 31 is invalid. But then once it gets to 32, we put 32, and that's it. And coding this up is pretty easy. I'll go ahead and show you how to do it both the simple way and the more clever way. All right, so this is the coding portion of everything. So first things first, I wanted to just do the simple way, right? And for our sliding window, I actually want to make a inner function first, and that function is going to be called validate window, and it's going to take a left pointer, a right pointer, and then it's going to return a boolean determining whether our window is valid. So first thing we're going to do is set a pointer right here, I, which is to our left pointer, and basically the beginning of our window, if you think about it, right? And then while I is less than our right pointer right over here, we want to ask the question, okay, so is the num, let me put some parentheses, right? If number at this I pointer right here, plus 1, right, because we want to make sure it's consecutive, is equal, or doesn't equal to the number at the following index, right? If it doesn't equal that, then we want to return false, right? And this is a while loop, so we're going to have to just manually increment our pointer here over here. And then if we get out of the while loop here, then we know for sure that we have a valid window. So return true. Okay, cool. Now we can do our actual setup. So left pointer should be equal to 0. Our right pointer should be equal to k minus 1. And that's because our it's 0 index, so we're just doing the length of our window is k, so we're just subtracting 1 to fix that. We're going to have a result array right here. We're going to start our result. So while our right pointer is less than the length of nums, we're going to ask the question if validate window. So we're going to pass our left pointer or right pointer. If it's valid, then we know that we can just simply append whatever's at right pointer, right? That's going to be the biggest number. Else, we can just simply put -1. All right, and then we're going to manually increment our pointers right here. So increment that by 1, increment that by 1, and that's pretty much it. So let's just run it, just make sure it works. It does work. Submit it. Okay, easy peasy. Not too bad. Okay. So let's just do the more optimized way with counting. So first things first, I'm gonna write count is equal to 0, right? And then I'm going to have a variable that holds the previous one, right? Because we want to make sure we're in consecutive order. So the previous variable in this case is actually going to be the first number in our numbers array -1. It'll make sense in a second. And I'm going to hold this result array right here. The next thing I want to do is I'm going to do for I and enumerate, right? Enumerate nums. And the reason I'm doing this is because I want to hold the index and the actual number. And this enumerate trick is pretty useful for that. And so I'm going to ask the question, okay, if our current number, right, current number is equal to previous number plus 1, just make sure it's in ascending order, right? And that's why I set it to the first number minus 1, so it effectively cancels out. We can just increment our count by 1. Else, we're just going to reset it back to 1. Okay, cool. So here comes our second part. So I mentioned kind of earlier, once we go past our window, we want to start appending to our result array. So if the index is greater than or equal to k minus 1, now we can ask the question. If count is greater than or equal to k itself, then we simply can just append whatever's at where we're at right now. And then otherwise, we're going to put -1. And the last thing we have to do, we can't forget right here, is we're going to reset our previous one back to n. Right? And that should be it. And that runs, and we submitted it. And that's pretty dang fast, huh? Alright, so if you like this explanation, be sure to leave me a like and any feedback. Thank you.